I'm running out of paper.
All right. Got a busy 3 days here this week leading up to our quiz, which is going to be on Thursday. Okay? I talked one time, I wasn't sure if it'd be next week. It really probably would, if it was going to be next week, it'd be Monday, and I'm not sure that's a great situation after a 3-day weekend. So we'll be able to I think, get to this just fine by Thursday. Now that may mean, you've got to make sure that you come in and see me if you've got some questions. The stuff we do this week, very, very important conceptually as we go into later chapters and the rest of what we do with derivatives. We've been talking about these connections between F and F prime, and we're going to formalize that and write it. I said we start organizing our thoughts on that a little bit. We're going to really do a lot of that today. Got a little activity with some matching graphs and stuff that we're going to do today as well. Try to get all through that with still some time for you to work on some homework here to get done. This was a very short assignment here that you had today. Won't be quite as short going forward, but really need to spend some time with it and see what it is that you have questions on. Try not to all of a sudden come in Thursday morning before the quiz with all your questions, right? But, so that's what we're going to do here. Here's the notes, or one thing that we kind of ended up with at the end of the day on Friday was this thing called the first derivative test. We wrote this down. I think you probably have it already if you wrote it down on Friday. We did that activity on the calculators. Now those of you that were gone, I'd have to send that to you. But if you want to do that and go through that, but essentially we went through that worksheet and we arrived at this. Now we're not going to hand that in. However, we are going to hand in reaction articles. Why don't we do that right now? Get that done. Those reaction articles that I assigned you on Thursday. Go ahead and turn those in. I know I got one or two shared it with me on the Google Doc platform, but make sure your name's on it. Just pass those up. And we'll talk about that later in the week after I get a chance to read through everybody.
Do you want the actual article?
No. Bailey wrote his own. Okay, is that it? Going once, or twice. Okay. All right. So back to this. This thing called the first derivative test. What we ended up finding out about this is that if you have a critical point at x equals a. Now, what was a critical point? When, by definition, a critical point is slope is 0 or undefined. Okay, a point on the f graph where the slope is 0 or the slope is undefined. Or we could say f prime is 0 or f prime is undefined. Okay. So if x equals a is a critical point, either the slope is 0 or the slope is undefined, one of 5 things could happen, we said. You could have this, where the slope is 0. You could have this, where the slope is 0. You could have a flat spot, where the slope is 0. You could have this, where the slope is undefined. Now you could have that, I guess, upside down, so maybe we should say 6 things. You could have a local max or local min, but it's a sharp point. So the slope is undefined, or you could have a vertical tangent, which also is a place where the slope is undefined. So those are potential critical points. So if you have a critical point, then f will be a local max if f prime changes from positive to negative. So if you look at the two that are local maxes, it'd be this one and this one. What happens when you have a local max? The slope is positive before that point and negative after that point. In a flat spot here, the slope's positive and then stays positive. here the slope is positive and then stays positive. Okay, and of course we could have a vertical tangent, I guess it goes down. Oops, it goes like this and goes down and then does that, so that could be a vertical tangent as well. Okay? You have a local min, which would be here and here, if the slope is negative and then changes to positive. Because, okay, so if f prime is negative and changes to positive, then the f graph was going down, then was going up, and that's a local minimum. Okay, so that's called the first derivative test because we use the first derivative, we use f prime to tell us if f has a local max or min. And it's simply going down and up is a local min, up and down is a local max, slopes are positive to negative or negative to positive. That's the first derivative test. Okay, so we came up with that on that little worksheet. Then we had this short assignment. I want to talk through number 7 and 10, and we'll review 16 through 20 very quickly. So 7 says, explain the difference between a local max and a local min. Well, a local max is a peak or a valley. A local max or local min is at a high point in a small region. Now, one thing about local max and local min is they are not at endpoints. I mean, if you want to jot that down, you know, you could, but that's something that you'll hear me say probably repeatedly. Local max and local min will not occur at endpoints of an interval. For local max or local min, we want it to go up and down, or down and up. We want there to be a peak or a valley for a local max or local min. A global max or global min is the highest point or the lowest point. Now sometimes we use the term extrema or extreme values for max and min. That way we can use one word instead of two. Instead of max or min, we can just say extremes. But a global is the highest or the lowest. So that could happen at an edge, okay, at an endpoint. You could have the highest point, okay? But it also could be at a local max or min. All right, so that's the difference between local and global, and we'll see more of that as we go. 10, what is the relationship between a stationary point and the function's extreme values? I would say something like this. If we go back, oh, I can't go back. The examples I just had up there. What I would say is a stationary point is one possibility where a function could have extreme value. A stationary point is one possibility where a function could have extreme values. Where else could it have extreme values? Where the derivative is undefined, right? It could be at a stationary point, which is where the derivative is 0, but it could also be when the derivative is undefined, or it could be at an endpoint. If we're talking about global extreme, it could be at an endpoint. So I would say the relationship would be stationary point is one place you could look to find extreme value. All right, 16 through 20 have to do with this. The next quiz will have a lot of questions like this, and your homework over the next couple of days will have a lot of questions like this where you have a graph. It's either the f graph or the f prime graph, or maybe the f double prime graph, which we'll talk about tomorrow. And then they ask you questions about it. And they ask you questions about increasing and decreasing, inflection points, and concave up, concave down, local max, local min, all this stuff we've been talking about. So 16 says, at which point is f prime positive? Point or points? At A and at D. Because this is f now. F prime is positive means when the slopes are positive. This means f has to be going up. That happens at A and D. 17. Between which points does f have a stationary point? Between A and B and between C and D. Stationary point would be where derivative 0. That'd be at that local max and then again at the local min. 18. Between which pair of points is there an inflection point of f? Between B and C, we have an inflection point. Change in concavity. Here's the trickiest one probably. Where is f prime increasing? Between C and D. When f prime is increasing, f is, okay. Well, there is actually. When f, and we'll get into that today. When f prime is increasing, F is no? Okay. All right. Hang on. All right. Let's talk about it a little more, and then I think you'll get it. Okay, F prime is increasing. I heard some stuff like positive getting less positive, stuff like that, negative getting more, whatever, or more positive. Let's go that way. So F prime increasing. There's two different ways that numbers can increase, at least as far as for us to, for what I like to use here. You could have positive numbers that are getting more positive, or you could have negative numbers that are getting less negative, correct? But now we're talking about F prime here, so we're talking about slopes. So what we have are slopes that are positive and getting more positive, or we have negative slopes that are negative and getting less negative. Concave up. Wouldn't those two situations be concave up? That's right, what we were saying, there's no good way to say it. That would be the good way to say it. When F prime is increasing, F is concave up, right? Because right here at C, well, even before that, at the inflection point, actually, we've got negative slopes that are getting less negative. So F prime is increasing because it's negative and getting less negative. And then, starting at the local minimum, we've got positive slopes that are getting more positive. Again, F prime is increasing. So in both of those situations, negative and getting less negative and positive and getting more positive, both of those situations describe a curve that is concave up. So when F prime is increasing, F is concave up. We're going to list that up here in a minute, okay? But that is why the answer is between C and D, because that's where it's concave up. All right, 20. Where does F prime have its minimum value? At the inflection point. It's between B and C. Now, here's another where I want to talk about this negative-positive business. Where is its minimum value, which means its minimum output? And we're talking about F prime now, right? Well, what does it mean, a minimum value? It means the littlest, right? Well, what if all the values were positive? What's the littlest? The one that's least positive, the one closest to zero, right? If all the values are positive, the minimum value would be the one that's closest to zero, the least positive. But if you have some positive and some negative values, what's the littlest value? The one that's the most negative, correct? Does that make sense? So now we're talking about F prime. F prime is a slopes. So in this picture, we have slopes that are both positive and negative, right? So the minimum would be the place where it's the most negative slope. And that would happen right there at the inflection point. That's when this has the most negative value. And that'd be the minimum value. So at the inflection point. Okay, so that's, we're going to expand on some of those ideas here a little bit today. All right, so next thing I would like to do is turn back to page 55 and look at this picture right here. Now, everybody's here today. We did have one person miss in the air class, so I am recording this. But and this maybe you want to go back and look over some of this or listen to some of this as well. But here is something much like we were looking at on our calculator the other day. We got an F graph on the left, and we got an F prime graph on the right. Okay? What I want to do is list the connections between F prime and F, and I have you put this in your notes. Okay? So we are going to list the connections between F prime and F. And we're going to do it in a somewhat orderly manner here. So the first thing I would like to do is we're going to focus on the right-hand graph for now, the f prime graph. And I first want to look at point A and point C, or A prime and C prime, I guess. What is true about f prime there? It's 0. The y value of f prime is 0 at those points. So, one thing that can happen is that f prime could equal 0. Now, what is true about f at those points? Local maximum, but what do we call that by definition? When f prime is 0, that is stationary point, right? Critical point includes undefined. So we're going to forget about undefined for right now. Okay, there might be some questions about f prime undefined, but for our connections, we're going to forget about f prime being undefined. We're focused on stationary point. So when f prime is 0, f has a stationary point. Okay? Now I heard somebody say local max, local min. That's true. There are some of that on f2, but we're going to get into that more specifically. But if f prime is 0, f has a stationary point. So there's two stationary points here. Two places where f prime is 0. Okay? Here's a second thing we could say about f prime. How about before this first stationary point? Before this point, what could you tell me about f prime? Okay, and you guys are going to, you said less positive, and some people might say it's decreasing. Both of those are getting more detail than I want to get. How about let's just say it's positive, right? Would you buy that? Before point A, f prime is positive. It's above the x-axis. Now you're going to do an activity here where you're going to be looking at some f graphs and f prime graphs and trying to match them up. I think you want to focus in on the easiest part you can. And the easiest part of an f prime graph that tells us some good information is when it's above the x-axis and when it's below the x-axis. Because above it's positive, we're talking about its y values now, and below the y values are negative. So one thing we can say about f prime is when f prime is positive, what does that tell me about f? F is, and I'm going to put just an up arrow like so, f is increasing. Isn't that true? When f prime is above the x-axis, look at the first part of the f prime graph here, the f graph is going up until point A. We're listing connections between f prime and f. So if f prime is this, what's that mean for the f graph? So the next one is probably what? When f prime is negative, f is decreasing. So when this f prime graph is below the x-axis, which is all the way from A to C, this graph is below the x-axis, the f graph is decreasing from A to C. All right, now let's let's combine that with what we learned on Friday. What happens to the f prime graph at point A prime? What happens right here? Right? That's what we just had up a minute ago. It's what we learned on that first derivative test. Right at A prime, f prime changes from positive, and I sometimes will go in and actually write that in like that. Put a plus and a minus. It's going from positive to negative. Okay? So let's write that down. If f prime, we're writing this basically again because you had it in the first derivative test, goes, that's shorter than changes, same thing, changes probably better. If f prime goes from positive to negative, comma, f goes from increasing to decreasing. Is that not true? If f prime goes from positive to negative, we can see back in 2 and 3, if f prime is positive, it's increasing. F prime negative, f is decreasing. So if f prime changes from positive to negative, f has to change from increasing to decreasing. And if f goes from up to down, what do you got? Local max. We got a local max. If f prime goes from positive to negative, f goes from increasing to decreasing. That's what makes a local max. And so you can probably guess what 5 is going to be. The reverse of that, if f prime goes from negative to positive. F goes from decrease to increase. And if an F graph goes from decrease to increase, what do you got? Local min. So those two together make up the first derivative test. Right? 4 and 5 are essentially the first derivative test. Now we've pretty much exhausted everything that can happen with f prime being either positive or negative or 0, which of course are its only possible values, positive or negative or 0. So from that, what we've learned is that if we are looking at an f prime graph, the first and most important thing to do is look at its outputs as far as being above the x-axis, below the x-axis, or right on the x-axis. And then also when it hits the x-axis, if it's changing from positive to negative or negative to positive. All right, now if we just take a second to investigate what could possibly happen there, before we move on, we do have some other connections to make. I don't know, you don't have to write this part down right here. But let's talk about that, an f prime graph where it's going to equal 0, because we're really interested in that, where it equals 0 or where it's positive or negative. And of course, anytime it changes from positive to negative, it's probably got to go through 0. Unless we get one of these undefined kind of things jumping around, and those special cases we'll deal with. Well, what are the possibilities? The only way the f prime graph can hit 0 is to come from up here and come down through. Well, that's positive changing to negative. So what do we got on the f graph there? Is that going to be a local max? F prime changes from positive to negative. And we could also have an f prime graph that comes up this way, changes from negative to positive. What do we got? Local min. But that's not all. An f prime graph could come down, oops, hit and bounce. So f prime is 0. You do have a stationary point, but f prime was positive and stayed positive. That's a flat spot. Because what's f? If f prime is positive, f is increasing, then slope is 0, so it flattens, and then it goes positive again. So it keeps going up. So this would, an f prime graph that did this would be a flat spot on f. Or then the other possibility, are there any other possibilities in this right here? Are there any other ways that the graph could cross the x-axis? I think this is pretty, or hit the x-axis, excuse me. Right? It's got to go from positive down to negative, from negative up to positive, or be negative, hit, and then stay negative. So you'd have a graph that's going down, 0 slope, and then negative slope again. Again, flat spot. So these two would be flat spots of f. This would be a local minimum of f. This would be a local max. Okay, so there's graphically what this first derivative test would look like. Okay. All right, back to our connections here. So there's some more. All right. Number 6. What's happening on the f prime graph from the beginning, from the far left, all the way to B? F prime graph now. No, F prime now. Now F prime's concave up the whole time. But what's F prime from here down to B? Decreasing. The F prime graph is decreasing the whole time from the left edge down to B. So F prime is decreasing. F is what? Concave down. What is F? Oh, now that's what we were just talking about in problem 19. right? And that we had a little trouble with that. That was a little tricky for us. What's going on there? If f prime is decreasing, well, there's two ways something can decrease. It can be negative and get more negative, right? So if f prime is negative, remember f prime is slopes. So if the slopes are negative and getting more negative, that would be this, right? Oh, that's concave down. What's another way to decrease with positives? Positive slopes, but yet less positive. Oh, that's also concave down. So when f prime is decreasing, f is concave down. So likewise, I think we had this on number 19, if f prime is increasing, f is concave up. And we can see that in this picture here on page 55. F prime is going down all the way to B. The f graph is concave down all the way to B. The f graph is going up, or excuse me, the f prime graph is going up from B to the right, and on the f graph, it's concave up from B to the right. Now, let's do what we did in 4 and 5. Let's talk about the change. What happens at point B? At point B, f prime goes from decreasing to increasing, right? F prime now I'm talking about, not F. I'm talking about F prime goes from decreasing to increasing. What's F do? It goes from concave down to concave up, which is a change in concavity, which is an inflection point. So let's look at this a minute on 6 and 7 here. So if F prime goes from decreasing to increasing, F would go from concave down to concave up. But what if you did vice versa? In other words, does it matter which order? No. Now over here it did. If f prime goes from positive to negative, you have increasing f to decreasing f. That's a local max. If you reverse it, it's a local min. So the order matters. Here it doesn't matter. Any change in concavity is inflection point. It doesn't matter if it changes concave down to concave up or vice versa. So we can put this all in one. So our last one here is going to be if f prime goes from increase to decrease or vice versa, f goes from concave up to concave down or vice versa. So f has an IP, inflection point. Now think about what the f prime graph looks like when you have an inflection point of f then. If f prime is going to be going up then down or down then up, what do you got? If f prime is going down then up or up then down, what's that look? It looks like a local max or min, right? I mean, look at this. Down here on f prime was a local min. That actually corresponded to the inflection point of f. Interesting. Now, we don't want to confuse that with the local max and mins of f, right? The local max and mins of f were when f prime was 0. But it looks like the local min on f prime corresponded to the inflection point on f. But again, why is that? Well, because at the local min, f prime changed from decreasing to increasing. Well, if f prime's decreasing, f's concave down. If f prime's increasing, f is concave up. So if you go from one to the other, this goes from one to the other. Change in concavity, you got an inflection point. So again, your head starts spinning, a lot of stuff going on. All right? But we're going to organize this here in just a second. Okay, but before we do, we've got that up there. We've got these connections. I want you to be able to look at a graph of f prime and try to picture what f is. That's probably the most important direction to go. Now, yes, I would like you to be able to look at an f graph and be able to do an f prime. On your homework, we're going to do one together, and you've got a couple on your homework, where they give you an f prime graph, and you have to sketch the f graph from that. And then you may have to do some of that on the quiz. Not as much do we do the other way. Here's an f graph, sketch the f prime graph. But you should work both ways. So this little matching activity we're going to do today, and you're going to have to get in groups of 2, probably 3. I only have 9 sets, so that probably means 3 in a group, okay, at least. Now, here's what this is going to look like. First, let me hand out the sheet. We won't be turning these in, but everybody, just so everybody kind of focuses in here, I think if you all fill it out, it'll be good. And we're going to fill out the second column for sure. And then if you're a little bit ahead, you can get a little more of it filled in, that's okay. And I'll explain what I'm talking about here. All right. So each group will come up and get one set of these cards here. Now, there's the F for the function graph, and there's the D cards for the derivative graph. Now, for example, here's a couple of F graphs right here. Okay? And then there's some that are labeled with D. D is for derivative. So the D graphs are the F prime graphs. And so you're going to match, okay, so if F2 went with D7, in this column you'd write D7. Okay? Now the other columns, if you get time, I don't care as much about this, but if you get done, some groups will get done fairly quickly, some may talk about it more and take longer. So if you get this column all filled in, then you can go over and work on these other two columns, which are these descriptions. Okay? So here's a description of the derivative graph. The slope of the derivative graph is always equal to 2. So you'd be looking for a graph that went down and always had a slope of -2. And you'd look to match that. So, and that's good. That'd be good practice too. It uses a lot of terms like local max, min, inflection point, stuff that we need to do. So if you get to that point, it'd be good. But the main thing we want to do is match the function graphs with the derivative. So what I'd like for you to do is start with the D graphs. You know, sort out all the D graphs, sort out all the F graphs. Start with the D graphs. So let's say you pull up D7 here. Okay? So you pull up D7 and you're saying, okay, that's the derivative graph. Now this is like the one we just had up there, isn't it? Same exact thing. So what would you do? You'd be thinking to yourself, okay, if I was looking at this as an F prime graph, I'd first focus on the fact this is positive. Then it turns negative. Then it's positive. Above the x-axis, below, then above again. So I'm looking for a graph that has positive slopes first, so it goes up, then negative slopes next, so it goes down, and then positive slopes next, so it goes up. So I'd be looking for something that goes up, down, up. Well, I think I had it up there, didn't I? Yep. That probably was it. Well, that was good. Okay? Now there's several of them, though, that are close to one another, so you want to be careful with that. But that's basically it. So it may only take 10 minutes. I mean, this may not take very long to get through them all. But and if you're not sure in your group and it went a little fast, you can check some of these out for me and take them home, later in the week or whatever if you want to go through this again. But so each group needs one of these, and try to get that matching. And we'll go for 15 minutes, 20, whatever it takes here. At least get that far. If you get the second column filled in, go ahead and do some of those. As soon as everybody gets that second column filled in, we'll move on. Okay? So, groups of 3, come up and grab a set here.
You want to keep that printed? You want to be in our group? Sure. We want green.
We could probably have one group of 2, maybe 2 groups of 2 class work.
We're all sitting right here.
I'll be over here.
Yeah, sure.
Oh my gosh, I like this sweatshirt. It's so cute.
I used to stand in time.
Hey, let's create a roadblock.
Yeah, we already discussed this. Excuse me. So,
Where's the D's?
right there.
Shut up.
I think I'm funny. I can't work. I remember it in middle school. You were being really and as well. I spend too much of my life saving. It's okay, I'm lazy all the other time.
Yeah, I would recommend starting with the derivative graph. So you'll be filling in the second column out of order probably, right? I think it's best to start with the derivative graphs. And I probably should have just done it that way on the thing, just filled it out that way.
Yeah.
I think that was next. Great. I like it.
This is what's known as my lab. It's just long because I write so large. It's gonna be a sign graph.
Hey, this is the one that was up on the board. Which is the squiggly. Yeah. I don't want to do that one now.
Bingo.
Okay, now that's knock out days. Why? It doesn't ink on it.
Never worked out yet. That's how they do it. Oh, so that's all. You know that's you know.
What's that? I think they do. I think.
Wait, we didn't discuss this one. Okay.
Got one room.
So. Okay, there's all the functions that they do over there. Maybe not.
Oh, okay, it's not
Function description. Function has over here. Wow, yes. This is all about the functions. This is we consider things like this. Maybe FTD. Yeah. Oh, guys, there's the G.
No, because that's high ground.
Oh, those are the. Yes. Side, no. Side, ahead. It has a local.
Well, I assume you guys all.
Wait.
Oh, wait.
It's really high at 2 and 2.
Oh, wait.
This one, she has it upside down. Wait. I know, come on. F1 is a 3. Wait. Function 3 is middle arrow. Wait, nope, I have two.
They're not.
Two. 2 towers. This potion has 4 critical chords. Critical point is 0 in it.
What was that other one?
Zero.
So many choices. Or we could, that's positive.
I'm shaking your head.
I don't know, as a horizontal
I disagree.
From positive to negative.
That's
Right, it's 0. Option 7 is 2. Good one.
that's what I don't. You can cross that. Oh, yeah. Oh, wait, no, but what exactly? I know it's not.
Here. See a lot of this.
If you cross it, but then the two ends of it, then the two ends.
0, 0, 0.
Approach it.
Well,
So like for the F10 crosses.
Alrighty then. Little F4. This is a graphical linear function.
I'm gonna,
That was nice.
yeah. I'm like, horizontal.
It's a big.
I get horizontal.
It's a sine graph.
Figure out this for you.
Sucks.
It says the straight line,
I don't
horizontal,
believe it.
vertical, straight lines for each graph.
That's right, that's what
I ain't gonna have time, guys.
So I think that one would make sense, F10 makes sense.
Come on.
Is that all of our things?
This is a graph of a quadratic
He only grabbed a ton of straight too. The first one you pointed at, stared at for 3 minutes, and was like, no, it can't be that one. And I'm even looking at it backwards.
This is the graph of a linear. I'm guessing it's a line.
I think it might be. Oh, guys, let's think about it.
Are you not sorting the
Y equals 0. It approaches but never touches.
Flattens out right there.
Yeah, you're like, oh, okay. Wait a minute, no.
Just kidding.
Wait a minute,
No, you're
guys.
right. Really? That's not what's on the
Yeah. Gotta be saying it from my perspective, Alex.
Wait, that's a derivative. Oh, yeah, that's G7.
Okay. Let's not get too hasty now, gentlemen.
Right up
No,
there.
every time we get done.
Notice how.
Guys, are so
Why measure
organized.
positive?
You're so unorganized, gosh.
This function has a point of inflection.
No.
Sit there.
Yeah. Right in front of the graph.
This one starts.
Now you have to wait.
Starts going up. And this becomes.
On this graph, x equals
So that
negative
means
2.
this graph goes down. It has to stay. So we want to graph.
So it has to have no curve.
Starts going up.
Yeah.
Goes down.
Okay, so that F1 is.
Supposed to be F11.
It's supposed to be a fan.
As long as these guys are all negative. This one.
This is the graph.
I just thought absolute value was like.
So what you were.
This cavity is valve is an infection. That is me.
This graph starts going down.
That's on the 3.
So that means it's.
Lay out all the graphs.
I had to like, I had to
Negative,
like,
negative, so we need
headphones
to
to
graph.
positive.
Low start.
This on function has a
If you look at it
We have time to do the derivative. You're good, guys. We're booking.
I'm going up.
Bob.
Alright, let's pull out. Are we supposed to get
Bob.
whatever? I need something.
Bob. Have you guys seen
Very different.
fired up?
Plus, some people just
So,
look at it, it's like it's not a monster.
Wait, it has to be negative.
That's different.
Yours is.
Okay.
Wait. He says.
Oh, yeah.
Wait, 15 out of 1. And his name is 6.
Hey, a couple more minutes here.
I can't.
Hurry, guys, let's do this. Let's look at this graph. Let Nick all done.
Oh, this is hard. Yeah, look at the derivative graph column.
I don't think so, because look,
D.
here the derivative, the y values are negative, so it's gonna start going down, which it does. And it's positive, so then it's negative, so it's gonna go down. And then it ends up positive, and it's gonna come back up.
Graph.
So maybe that.
Yeah, I found it.
So the graph. So which number am I looking Negative and positive. The graph is the graph.
Why you throw it on my paper? Oh, boy. Tyler.
So the derivative of your, so the prime graph, this is negative and constant. So wouldn't it just be negative?
This way.
The graph of the derivative, does that mean of the?
It means the D
You would like
graph,
that.
so it means the D graph is negative and constant.
This is how we do it.
So that would be
Oh,
Negative
what
and
the?
positive.
What did we do? It changes. Yeah.
So the line that has
Huh?
taking the F when F gets five.
These Y values are negatives, this goes down, and then Y values are positives, this goes
What did you do for an absolute
The only one where it's only negative.
The graph of this derivative is positive when x is greater than 0 and is negative when x, or x is less than 0 and is negative when x is greater than 0.
Yeah, they all are, yeah.
Yeah, that one.
Oh.
When x is less than negative 2, which is in between 0 and 2, it's negative.
That's because this is up, down, up.
Yep, that's.
I disagree.
The derivative is always greater than
Yeah. Okay, you know what, Alex, you can write that one down.
I think they're about ready to.
Wait, so, oh. So wait, E is F. Wait.
Then you can start looking at local.
It's okay, I have the other three, so I'll just figure it out.
Negative stays up, down, keeps going. So that's up, down, flat, keeps going.
Yeah, right. Wait, okay. So this one has a line on it, and that makes it right. I read, guys.
These are, these Y values are positive, it's the negative. So that means
So one of them was probably negative 4. Yeah.
positive, negative.
Okay, so that's what it's supposed to be, because that's
And
one.
if you look at the slopes are positive.
You ever got the answer why it's so great?
Oh God. Oh God.
Let's figure out the other one.
That's not what
That's already
Some more days, it'll come. All right, hey guys, good job. Let's shuffle them up. Let's shuffle them up. Everybody's got that second column, which is the really key thing we wanted. Shuffle them up and flip them and bring them up to me. And then move your desk back. We got a lot we got to get to, and I want to give you some work time. So.
Oh,
That's right.
If you got some of the other columns, I'll let you see the answer sheet later if you want to check them. See how you did. Okay, thank you. Any more cards here? Okay, now, like I said, later this week, tonight, tomorrow, whatever, you want to take a set of these home. You only got 9 of them, but you want to take them and practice it a little bit more. If somebody in your group was zipping through it and you were like, yeah, I'm not sure what they were doing there, you know, feel free to come see me and do that. But let's take a look at your notes now again here, and what we have up on the board. And what I would like to do is take these 8 connections here and kind of organize this now again, because a lot of you, I noticed as you were doing this, you were referring to your notes of this up here. You were saying, okay, when F prime's positive, you know, and literally sometimes you close your eyes and you think, okay, this, then this, you look at your notes and, you know, and look at these connections. I think that's fine, okay? But if we had a little more compact, more memorable way to put this together, it might be helpful. So, what I'm going to do here is we're going to make a chart. Not a chart, but the chart. Ask somebody in calculus from last year about the chart, and they would be able to draw it for you probably. Okay?
Probably.
Now, that's not very good. The lines aren't very straight as you've come to learn. But when you get your quiz on Thursday, my guess is for many of you, the first thing you'll do, even before writing your name at the top, will be to jot down the chart. Okay? Because there'll be a lot of questions on the quiz about this interrelationship between F and F prime. Okay? And so here's what this will look like. Now we'll be adding to this over the next couple days, but we're going to have 3 rows. One for F prime, and one for F double prime. Now we'll add in F double prime tomorrow. For right now, it'll just be F and F prime. Okay? And so we're just going to go right down through the numbers in our list of connections. And we're going to focus in on the middle row, the F prime row. So the first thing we talked about F prime could be 0. And if F prime is 0, what's that tell us about F? It's a stationary point. Now I'm going to squeeze a lot in this little box, and so you'll probably redraw your chart multiple times to make it look nicer and so forth, so don't get too worried about neatness and stuff here. But I'm going to put that at the top of that box. That's a stationary point of F, and that could be one of 3 possibilities. What could I have on F when the slope is 0? Local max, local min, or flat spot, right? So I'll go ahead and write those in there. All right? When F prime is 0, F is a stationary point, and that could be a local max, could be a local min, could be a flat spot on F. Okay, the next column. F prime could be positive. If F prime is positive, what's F? Increasing. So this would just be a little more organized, a little shorter way to categorize all our information. If F prime is negative, F is decreasing. Now, 4 and 5 over here in our list of connections, the first derivative test. If F prime goes from positive to negative or from negative to positive, that would be like switching from one column to the next. So I'll just put some arrows down here and label that the first derivative test. Okay, if we switch from the second column to the first column, if F prime goes from a positive to a negative, then the F will switch from the second to the third column. The F will go from increasing to decreasing, which is a local max. And vice versa. If we switch from the third column to the second column, if F prime is negative switching to positive, F prime is decreasing switching to increasing, which is a local min. So 4 and 5 are hidden right there in the chart. The first derivative test is right there if you switch those 2 columns, or if you go from one column to the other. All right, then we go up to 6. If F prime is let's do increasing first, actually. That's how I usually do it. If F prime is increasing, then F is, so this is actually number 7 up there, concave up. If F prime is increasing, F is concave up. And likewise, if F prime is decreasing, F is concave down. So when you practice writing the chart, if you are so inclined to do, The key is start with that middle row. The middle row, f prime, could be 0, could be positive, could be negative, could be increasing, could be decreasing. It kind of makes sense. Those are all the possibilities of what f prime could be. And then what does that mean for f? And you fill that in. It's pretty easy to do. Now we bring in f double prime tomorrow, and we'll see some other connections, interconnections going on in there. So we'll have a little bit to add to it. And then number 8, if f prime goes from increasing to decreasing or vice versa, that means if you switch these two columns, you have an inflection point. So if f prime switches from increasing to decreasing or the other way, then the f will switch from concave up to concave down or the other way, and that's an inflection point. When you have a change in concavity, you have an inflection point. Okay? So there's all 8 of those things kind of organized in that way. It seems to be something that people have liked over the years and been a good way to organize all that information. All right. So, homework. Let's do a couple here together and then get you off and running on your own. Here, if you don't have to do this neatly. If you want to sketch this here in your notes, this is just a picture, and this is similar to something you're going to have on your homework today. So it doesn't have to be real neat. Just draw yourself an XY axis. Put a dot at, I got 2, 5, and 9. Put a root there at those places. Put a max. Put another local max. Got a little bit of a local min here. It doesn't have to be incredibly neat. All right. With this, I think you have to do this a couple of times in the homework, where they give you an f prime graph. So this is very much like the matching activity we did, where I told you start with the d graph, the derivative graph, and try to find the f graph. But what we're going to do is try to sketch it from hand. Instead of match it, we're going to try to actually sketch it. And then you do have sometimes where they give you the f graph and you want to sketch the f prime, or you want to figure out what f prime. You want to be able to work out both ways. Okay? Now, I'm going to draw my graph on this same grid, but I'm going to use red, so it'll be easier to tell. You might want to, if you don't have different color, maybe do a dashed line, or maybe do it on a separate axis. It's up to you. Okay, usually you'll draw them separately on a separate axis. All right, so I'm going to begin to draw the graph of f, and I'm thinking about drawing. So what's your first thought here? Say that again. F prime, you mean? The f prime, these values are down here, so they're negative, but they're getting less negative. So what's that tell you about what you're about to draw? Doesn't your graph have to be going what direction, though? Doesn't have to be going down and flattening, concave up, right? If we put those things together. We've got an f prime that is negative but increasing. So if you look at your chart, an f prime that's negative and increasing is an f that's going down but is concave up. Now where am I going to start this f graph? Wherever you want. Right. Think about this now. We maybe didn't think about this before. If I started mine up here and started it going, you said it's going to go down but then be concave up, and somebody else started down here, wouldn't they both be right? If you have an f prime graph, let's think about this a minute. Those y values are the slopes of what I'm about to draw. So it tells me the up and the down and the curve. But does it tell me where it is? So if I vertically shift it, think about the sine graph. Remember we said if we plot the slopes of the sine graph, we got what? The cosine graph, remember that? If we plotted the slopes of the sine graph, we got cosine graph. What if you took the sine graph and shifted it up 3? You got a new graph now. Did you change those slopes at all? So if you graph those slopes, what do you get? you still get the cosine graph, right? So that's interesting. So when you have an f prime graph, when you're about to draw the f graph, you don't know where to put it. So here's what usually happens. In a problem like this where they give you the f prime graph, they usually say, oh, by the way, f of 0 is equal to 2. They give you a point on the f graph, which is like giving you a starting point. So let's say we had that. So now we're all going to start our graph at 2 because they gave us that. All right, so you said this graph should go down but flatten. So maybe something like this. Now, do we know how fast it goes down? Well, a little bit. We know that the slope's -2, so we know when it starts, it's got to go down pretty steep. But then it's going to be less steep because the slopes are negative. So maybe it goes down steeper than that. But right now I'm not too worried about that. Okay? We'll do a rough estimate here. Later on we'll learn to be a little more specific. But right now it's going down but getting less. And right here we got a 0 f prime. So that means it's 0 slope. Now what? Positive and getting more positive. So isn't this graph got to be going up now? To right there like that. Okay? What happens after that point? Positive but getting less positive. So isn't this graph still going up? But it's leveling. Right? It's leveling because right there at 5 I've got a 0 f prime, a 0 slope. So therefore the f graph has to be level, flat. Okay, now what? Oh, it stayed positive, right? It didn't go through the x-axis. The slopes are still positive. So what's this graph doing? Still going up and getting more steep, right? Positive and getting more positive. That's because this was a flat spot right here on 5. I didn't make it look very flat, but I can flatten that a little bit. There we go. Now what do we got after 7? Positive getting less positive. So this is still going up, but leveling. Now we got a local max at 9 because right here the f prime is going from positive to negative. That's the first derivative test. If f prime goes from positive to negative, then f has to go from up to down. That's a local max. So what's the last little bit then? Negative, so this is going down and getting more negative, and so it goes down for a while. So that red graph would be one possibility. Now yours might have started a little steeper and whatever, but roughly it should be that shape. Now if they had not told me that f of 0 is equal to 2, then I could have started that graph anywhere. So I could have had any vertical shift of that red graph would have been acceptable if they hadn't given me that point to start with. Okay, let's look at number 50. This is not one of your homework problems, but number 51 is, and I'm going to change up the assignment sheet here a little bit. So let's do number 50. And it says that f prime of x is equal to x plus 2. Now, so the only difference between this problem and the problem before is we started you with an f prime graph. Here they started you with an f prime equation. So what I would suggest is you graph it. Since everything we've been doing is with graphs, I would say let's graph it. Now, if this happens on the quiz, it would have to be a real easy one, or more likely I'll just give you the graph. But if I don't give you the graph, then maybe I'll let you, and it's a very complicated graph, I'll probably let you use a calculator. I haven't decided yet what we'll do. Probably no calculator, because most of what we're working with is graphs, so I'll probably just give you the graph. But hopefully everybody could graph this lump, right? Y equals x plus 2. So y-intercept of 2, slope of 1, something like this. So this would be your f prime graph right here. Now, one of the things they ask you in number 50 is they ask, there's like an ABC, part A, B, C, D. One of the things they ask you to do is graph f. Okay, but we'll skip that because we just got into doing one. You can do that on your own. But they ask you a few other questions. One of the questions they ask is, where is this graph, where is the f graph increasing? From where, in what interval, is the f graph increasing? From what? No? I don't think I've heard it yet. There we go. about it and think about the chart, when is F increasing? F is increasing when F prime is positive. So to answer that question, see now some of you are saying negative infinity to infinity. You were talking about this graph was increasing, right? I didn't ask when F prime was increasing. This is the F prime graph. I asked you when F is increasing. F is increasing when F prime is positive. Well, this graph is positive from -2 onward. Okay? All right. Part B then says, where, if any, does F have a stationary point? At x, and this is how you would want to write it, you would say at x equals -2. Don't put the point -2, 0, because F does not have a stationary point at -2, 0. You're talking about a point on the F prime graph, right? So you only want to give the x coordinate. Where does F have a stationary point? It has it at x equals -2. I don't know where it is on the F graph. I don't know where that stationary point will be, but, okay? So you just give the x coordinate. All right, C says, where does F have a local minimum, if any? Local minimum is when F prime goes from negative to positive. Right here, F prime goes from negative to positive. The local minimum is at x equals -2. And then finally, D says, where, if any, is F concave down? F is concave down when F prime is decreasing. When is F prime decreasing? Never. So the F graph is never concave down because the F prime graph is never decreasing. So these are the questions. This is how you use the chart to answer these kinds of questions from those graphs. All right. Your homework is section 1.6. I think it starts on page 61. We're going to change up the assignment sheet a little bit here. I'm going to add a couple today to it, and then tomorrow we'll do a combination of kind of section 6 and 7. So we're going to do 21 through 36, and we're going to do 46 and 51. Now 46 and 51 are kind of like that 50 that we just did there. And 21 through 36 are really two sets of problems. One, they give you an F graph and ask you some questions about it. And one, they give you an F prime graph and ask you a bunch of questions about it. Okay? All right. Go ahead and, sorry I didn't leave you a little more time, but we can get a little bit done, get a start on it anyway. 10 minutes. I'll be in here bright and early in the morning in case you want to go over some of this again. Again, don't save all your questions till Thursday morning before the quiz or Wednesday when we kind of review. Make sure you're keeping up each day.